Physical quantities and measurement. An analog voltmeter is used to take measurements of a constant potential difference across a resistor. For these measurements, describe one example of a systematic error. One example of a systematic error. Give the year number, and it's ideal if you can find the paper in your past paper book. But actually, he's asking for systematic error in the voltmeter. Actually, the question says, this is an analog voltmeter is used to take measurement of a constant PD across a resistor. So you have to give the answer regarding this resistor. So I have a resistor like I used to have in O level, and this is the resistor, and I have attached a voltmeter across it. Now, the most common zero error is the most common systematic error, which is famous in analog meter, is zero error. And zero error means that the meter does not show zero when the meter is switched off. A random error. Then he says random error. Now, in a meter, this is an analog meter, or you can say that if you are calibrating the readings wrongly, the most famous error here is parallax error. The PD across a resistor is measured as this. The resistors is labeled having a resistance, this 125 ohm plus minus 3%. Calculate the power dissipated by the resistor. The formula for power is VI. And now look the voltage. Okay, we can take the formula. It's actually the problem is coming because it's V. I should be using V square upon R. Now solve this. Calculate the power dissipated by the resistor. I have used V square upon R, and then he says percentage uncertainty. Uncertainty, I can check from here, V square upon R. I have to write a formula for uncertainty. This is the formula. He says percentage uncertainty, so I have to multiply by 100. Now I have made the formula, and as I always explain that you should make a presentation view. So I partition it, and then I have to put the values. Delta V upon V, which is 5 upon 0.1 upon 5. Now solve this. Everyone should take out the calculator and solve it. It is June 18, 23, 1. Please solve it and let me know the answer. Three 3.02. I'm getting 3.02. But other people should also contribute. the value of P was 0.2. In part number 2, we are not supposed to put the value of P, but in part number 3, we should put the value of P. So now solve this thing and let me know what answer is coming. Check the previous answer also. 0.023. But no one has given the previous answer. Only one student gave me 3.02. Double check that answer. And this answer is being suggested at 0.023. Different people are getting different answers. That's very strange. Point 1106. How the percentage can be so small? Did you multiply by 100? We have to first check our part 2 answer because different people are getting different answers. Actually, there is a square on it. Oh, this is my mistake. Actually, there is a square on V. There is a square on voltage. There is a square on the voltage. Now look at this. So please repeat this calculation first. Seven. The previous answer is repeated. Now do this calculation. 3.008. Everyone should first repair part 2 and then do part 3. Part 3. Solve part 3. Acha. 0.014. There is a suggestion 0.014. I will write it 0.01 for one significant figure. Oh, what I'm doing actually. Yes, you're right. Actually, what is about the test situation? Because you know what happens that if you announce point 2, look at this working. The 3 decimal place is never a condition, even it was not in our O level. That is right. Significant figure is a concern. And the rule I had told you in the class that the question should contain the same number of significant figure as the question as the thing. So you can write 0.20 here. And why you write 0.20? That is right, because you can say that I am showing 2 sig fig. And here I am showing 1 significant figure. Define velocity. Velocity definition is quite simple. It is the rate of change of displacement. Significant figure for uncertainty is always given correct to 1 sig fig. The speed of a sound wave through a gas of pressure P and density rho is given by the equation where K is a constant that has no unit. There is no unit for K. Examiner says K has no unit. Now read forward. An experiment is performed to determine the value of K. The data from the experiment are shown in the figure. Use data from 1.1 to calculate K. Now, V is equal to under root Kp upon rho. Square on both sides. Yes. Make the K the subject. Density is 1.29. Velocity is 3.3. He's not asking to put uncertainties in part one. And you can always look at the part two, because normally uncertainties he gives in the second part. So please solve this part, find the value of K and let me know. I have rounded it for two significant figure. Yes, in every part, you have to round the answer to the suitable number of sig fig. Now look at this screen, this working. Copy the working and copy the values. when uncertainties are given in percentage, they should be directly inserted. Now solve this part. Percentage, na? When you translate a percentage, when you remove the percentage sign, you always have to put up 100. So everyone should do this calculation quickly. The bracket solve 0.030. First answer is coming 0.030. Anyone else? Because the answer is looking a bit doubtful, because the number 0.03 is smaller than we are numbers we are adding. If I add 0.04 plus 0.06 plus 0.02, it should be something getting more than or at least near to 1. So other people can also please give support in calculation. Ahmed is saying 0.1447. Nothing, I explained nothing new. I was saying that do the calculation again using a calculator, because if every number is being added, it should be getting something more than 1. I got another answer, but other people should also help me. 0.04 plus 0.06, it's 0.1, 0.12 into 1.419. We can write it, but try to understand it's a fraction. If you write the values and get divide by percent, you will get the same answer. If you calculate 3% of that number and put it in the fraction, you will get the same answer. So remember the rule, percentages are directly inserted. It's a ratio. So ratio won't change. So other people can also please help to calculate 6.06. It is getting too big. How you can, how everyone is getting different answers? This is very strange for me. Point 0.06 plus 0.04 plus 0.02. Acha, 0.17. Another answer is giving 0.17. It's very strange for me that how different people are getting different answers in one calculation, even though it's very simple. Final answer I'm writing 1.42 plus 0.2. I have rounded 0.17. I have rounded 0.17 to 0.2. Yes, please ask the question. So this question is completed, and we have focused mainly on basic uncertainties because that topic is the challenging one. Other topics we have covered before also.